In this programme, we're exploring ways in which ICT can help with those aspects of maths that are hard to learn and hard to teach. Take ratio and proportion, for example. They're very similar, and pupils often confuse the two. Yet, they're separate mathematical concepts. Using ICT, we can help pupils develop mental images of each to avoid confusion.
And by the end of the lesson,
Liz Walker is an advanced skills teacher in Bexley. In the first of 2 lessons, she introduces ratio to her Year 4s, using ICT to help them develop a mental image of this abstract concept. Using presentation software in edit mode, the pupils will compare the number of blocks in different coloured towers and express this as a ratio.
So you're working with a partner to find 2 towers, move them to their left, and then to compare them by the number of cubes they've got in that tower. Ratio is quite an abstract topic for children, particularly at Year 4, where it's introduced to them. They need those visual images to be able to manipulate things.
Each group uses a paper spinner to randomly select the 2 coloured towers to be compared on each slide. The pupils then place the towers on the left of the screen and count the numbers of blocks in each. These numbers will form their ratio.
You've got to write down the ratio in words and then in numbers, like the number of blocks.
If you have yellow and a white, you need to write yellow and white in each square. So you've got a 1 and a 5.
I think using ICT within any lesson, does enhance the lesson. What we're comparing it with? But you need to make a judgment and make sure that actually that the ICT isn't going to get in the way of what the actual maths is, but it does provide a lot of visual images for them. Compared to? 2, okay. Click on the next slide down then, one of you with the pen. Just going to do the orange. Compared to the yellow. Right, click on the text.
The more able pupils work together on the interactive whiteboard. In addition to establishing the ratio, they're cancelling down to the smallest possible whole numbers to find what is called the base ratio.
Think what the ratio is going to be and can you put it into a lower form. Okay, have a go at that one. They were able to say what went into both the numbers and cancel down to its base, and they recognised that when you got to one of the numbers being 1, that was where they stopped.
This is the base.
Right, okay, now have a look what Emma's done. She's got it into a smaller base form again.
You can't have it anymore, or you'd go to negative numbers.
Good. Why can't you get it to 1 to 0?
You need 2 things to make a ratio, but as one would be 0, you couldn't compare it.
Well done. You wouldn't be able to compare 2 towers because there'd be no tower for one of them, wouldn't there? Okay.
With the pupils having explored simple ratios, Liz then introduces scaling up to the whole class.
I'm going to compare the pink tower, but this time I'm going to take 2 of them and I'm going to compare those with 2 yellow towers. How do you think we might record that ratio now?
You could put the other yellow blocks on top of the yellow blocks.
Right, so we've got a bigger tower now, and then do what, Daisy?
And then you could add both of them together.
And then what do you think the number should be for the pink then, Daisy?
Pink one would be 8.
8. Compared to, how many for the yellow?
10.
And what she's done is she's scaled up. She's thought, right, I've got 2 columns of each this time, so I've got to compare them, looking at both of the columns for each colour. So now she's come up...
In the final part of the lesson, Liz relates the abstract topic to an everyday situation, using pupils' own experiences to help reinforce the more complex concepts.
Remember, we've been thinking a lot about healthy eating, haven't we? Well, here's a nice healthy smoothie, okay? In my smoothie, if I'm making one smoothie, I have 5 strawberries to 4 apples. What about 3 smoothies? How many strawberries would I need? How many apples?
12 apples.
Why are you going for 12 apples?
Because they're going up in fours, and I know that 3 lots of 4 equals 12.
Well done. I've got 4 smoothies now. How many strawberries, how many apples will I need?
20 strawberries and 16 apples.
Right. Who agrees with her? Right, who can explain why they agree with her? Daisy, why do you agree?
Because we've been adding on 5 for the strawberries, and we've been adding 4 on for the apples, and I know that 4 lots of 4 is 16, and I know 4 lots of 5 is 20.
Well done. Do you think the computer's helped you to get these images in your head and record the ratio?
Yes!
Brilliant, well done, good work today.
So, what do the pupils think about using ICT in maths?
Computers are fun to use.
If you've got like a picture, it helps because so you can see what it is instead of imagining it in your head.
You can move the towers, and you can actually see them instead of drawing them or looking on there and then copying it onto your sheet.
When you use a computer in maths, it has lots of diagrams on it, and it can help you a lot.
If someone wanted to use the ICT that we've used today, I would say they need to make sure that they're familiar with presentation software and they're able to make their own presentations so that they can use those to then help the modelling with the children.
So at this 5-a-side match, the ratio of player to ball is 10-1. But if we want to describe parts of a whole, we use proportion. 10 players, 3 girls, 7 boys. So the proportion of players that are girls is 3/10.
Describe part of something.
Let's take a look at how Liz uses ICT to explore proportion with a group of Year 5s. To get the pupils thinking, Liz gets them to describe the various parts of a whole image on the interactive whiteboard.
We're going to start by having a look at our little tower here, okay? I want you to think, right, how tall's a tower? How's it made up? I want you to have a little chat with your talk partner next to you and think, right, how can I describe that tower?
Right, so we've got 4 green squares, 1 yellow square, they're all squares.
I think we've got some decisions so far. Right, okay, who's got something they can tell me about the tower?
There's 4 green squares and 1 yellow square.
Right, okay, so how tall is the tower in total? How many squares?
5.
5 squares. Right, so we've got a tower made up of 5 squares. 4 out of the 5 are green. So if we say it as a proportion statement, we say 4/5 are green. Because the way we're going to describe it as with proportion is as a fraction. Can anyone give me the fraction of the yellow one in the complete tower to describe the proportion of that one yellow one within the whole group? Joe, what would it be?
1/4 yellow.
Is it 1/4 are yellow? Let's think. You've got one yellow one.
1/5.
1/5. Why is it 1/5, not 1/4?
Because there's 1 yellow and 4 greens, and they make 5.
Good. So the total's out.
To help the pupils understand proportion in the real world, they're going to be using familiar images, drawings of the human body and photos of themselves.
Right, okay. There's a picture of someone, a normal person. Now, with most of us, generally, our body is in proportion. Now, have a look at this picture and have a chat with your partner and think, why does that picture look so strange?
Yeah. He looks fatter. Yeah. He's stretched out.
So why is it odd?
He's got a bigger head.
Right, so his head is bigger than it was in the last picture.
Yeah.
But his body and his arms, have they changed?
Yeah, he's shorter, and it looks like he's been stretched
Right,
out.
so his body's got shorter, but his head got bigger, so they're all out of proportion with each other, so it looks a bit strange, doesn't it? A bit odd. Now, someone over 400 years ago explored into this to find out whether our bodies were in proportion. Someone called Leonardo da Vinci.
In the 15th century, Leonardo da Vinci explored various statements about the proportions of the human body through his drawing of the Vitruvian Man. Today, the pupils are investigating Da Vinci's proposition that the length of our face fits exactly 8 times into the height of our body.
We're going to, first of all, take pictures of ourselves. Now, you have to stand exactly like the drawing. Now, you're going to have your feet together and your arms horizontal. Okay. I think when you have an abstract topic and you do relate it to the world around them, they do gain a much better understanding, and when you touch on it again later on, they're able to recall much clearer what they did the first time because it links to themselves.
James, move over that way a bit. No.
I think we need to do it quickly.
Right, you ready? Should I do it back there or colour it's big enough?
No.
There's your new picture. Okay.
And there's James all looking very serious, isn't he? Like? But yes, we've got the full length in. Good. We're going to upload it onto the laptop. So I put the disc into the floppy drive. Okay. Now, it's very important to be accurate. We want from the bottom of her chin to the top of her head. Okay.
The pupils use a photo editing program to copy and paste their faces 8 times. They'll then be ready to test Da Vinci's theory using the photos of themselves.
4, 5, 6, 7, 8. That should be about halfway the fourth one. Yeah.
Yeah, that will.
Yeah.
The students that this lesson would appeal to were quite a few distinct groups. The visual learners would be able to obviously watch and learn from the images that they saw. The kinesthetic learners were very much involved in doing things, so they would be able to take that skill with them to help them move on.
Double click on the image. There you go.
Yeah.
And then we did that one. We did that. There you go. Right.
So now we need to go.
So Morgan just didn't walk. So me and Joe was thinking, because our fringe was going down, and you and George was stuck up like that. Because look, my fringe is down, so our picture is a bit smaller.
So, do they think Da Vinci's proposition was right?
I believe it because Morgan didn't have a fringe down, so it could have been a bit more, and mine and Mark's fitted.
Now just use the slash line to show a fraction. 1/8 of what?
Is it 8?
Her body.
Of her body. Well done, Tasnia. Yeah, the proportion of Blaise's head is 1/8 of her body height.
With the pupils working on the computers, it's easy for Liz to access their work on the interactive whiteboard to help her in summing up the lesson.
Blaise and her group have thought, right, I've got 8 parts that make up one whole one. So we describe those 8 parts as 1/8. You should be able to say, I can describe part of something using proportion. Now, have you been able to describe your face within the body as a fraction?
What I found out today is that I didn't know that 8 of our heads go into our body, and that was like really surprising.
Bringing ICT can involve so many more skills that as a teacher I feel far more engaged in what I'm doing.
The visual nature of ICT can help us develop those all-important mental images that help us make sense of mathematics. Remember, if you'd like more information about anything in this programme, then log on to the Teachers TV website. Goodbye.